this window has, what does it showing? It's showing here. I can make a preview for the data, the data in the file. Okay, so what I see here, I see the column for the well name and column for the x coordinate, column for y coordinate, a column for the bushing, okay, which is the datum, a column for the top depth and bottom, another one for bottom depth, and one for the symbol of the well. You know the symbol. So each well has a symbol indicating if it's oil, another symbol if it's gas, if it's dry, and so on. Here I can see that the software has automatically identified these columns, but I need to double check from the numbers and the names. So the first column is the name, okay, so which is the well name. So I choose here in the attribute, I choose name, okay, and keep it without any changes. It will be as a text. The attribute type is text. So this is what it's all about in the first column. The second column is the x coordinates, okay. So I come and click on and choose surface X. Okay, I choose it. So what does it? What the software did is it identified the surface X or the geographic location according to the CRS that I identified. So it reads from the CRS. So this is the second column. I go to the third column, which is the Y coordinate. I go now to the surface Y. I click on it. I choose it. It identifies it identifies the location from the CRS. And after that, I go to the bushing, which is the datum. So in the column 4, I choose the datum. Okay, so it's will datum value. Okay, it will be, I can choose between meter and feet, but in this project it will be as we talked earlier in the CRS setting, we will keep it as meter. This is the column 4, and after that we have uh, top top we have the top depth, sorry, which is in the column 5. So what identified as TD. Okay, I also keep it in meter, and after that I don't need the bottom depth. Okay, but I need the symbol the symbol column. Okay, after the TD, which is I choose well symbol. I look for well symbol. Yes, this one. Okay, now I have only 6 column. I need to remove the rest of the column because I don't need them and they will cause me an error during uploading the data. So I highlight them. Once I highlight them, how to highlight them, you can click on the first column that you want to remove and scroll to the right until the end, the last one. Click on it, okay, press Shift key on the keyboard and click on the last one. They will be highlighted all, and you click on delete from this icon. You click on this icon to delete all the extra columns that you don't need. Okay, it's not done yet. There's something more we need to do. We need to define or tell Petrel the number of the header line. Okay, which is this line where we have the well name and coordinates and so on. We need to define the number of the headline so that Petrel can read after this line, can jump from this line and start reading the data in the arrays of the columns. So I put here number 1. If there are 2 columns, I put 2. If there are 3, I put 3. It's very important because if we don't do it, there will be error and the data of the wellhead will not be uploaded. Okay, nothing else to do in this part. You go and OK for all. It gives you this window that it shows you the um, um, the elevation, okay, it's in depth. The coordinate system, you need to make sure that this is the coordinate system that you have chosen. XYZ is undefined because there is no Z value, and also there is no ranges for X and Y. It's only point, local point. So you get just OK for all, and once you click OK for all the data of the wells will be showing in the input pane. Will be showing in the input pane. You can display them by click on the wheels here and all the data will be showing. Okay, so now um, this is now I'm showing the data. I'm showing the data in 2D window, but as I'm sorry, in 3D window, as I'm moving, okay, you can move the object inside the window by clicking on the hand icon here. So you click on it and you start moving the object. Okay, you can see that the wheels only the heads are displayed. Okay, not the extension of these wheels because we need to add the deviation data. Okay, so uh, to uh, to change the setting of the wheels, we can go to the wheels. Okay, double click on wheels and this window will be showing. Okay, but click on style and go to symbol. Okay, now here we can change the label size. Okay, if I want to change it from 75 to 150, I can click OK, and you can see that the text started getting bigger. I can make it much bigger, okay, to make it clear. So this is the names of my wells. Okay, let me reduce it to 300. Okay, it's better. I can change the icon or the symbol. Okay, also I can go from here 50 to 80 and click on it. And this is how okay, I put it back to 50. It's better. I keep the name, okay, as 200. And this is how I can okay, I can change the colors if I want from the label. If I want to keep them as well as the color of the well as well, it means that name, okay, or the label of the well will be colored according to the color of the icon of the well, or I can change it for black or white, or as attribute or as the folder of the wells, but I keep it as well the same for the symbol as well. So once you are comfortable with your setting, you can click OK, and don't forget to save. It's very important to save, and every step you go, you need to save your data so that you don't lose it. Now let's go to the second data we need to upload, which is the deviation. Okay, so what is the deviation when we talk about data deviation? Anybody know what's the deviation, or let's say or what's inclination data and azimuth data? What's inclination data and azimuth data? Anybody has an idea? Okay, when we drill a well, let's say for example we have this is land and this is my this is the drilling the rig. Okay, so it's when we say inclination or deviation, this means that we are talking about the angle between the vertical direction of the well, okay, and the deviation from this vertical direction. So it goes like this. So this is the deviation or inclination angle. When we talk about inclination angle, we are talking about this angle. This is inclination or deviation. And when we talk about azimuth, we are talking about the the well direction relative to the north. So if we have a north in this direction, we are drilling, for example, a horizontal well or trajectory or deviated well. Okay, so the deviation goes, for example, either this way or another will go this way. So we are talking about the angle, okay, the angle that deviate that deviate or can't or goes against the north direction. This is the inclination, and this is the azimuth data. It's important data to upload for all the wells. So I come how to upload it. We can go to the wells. Okay. By the way, we can upload this data individually, each well separately. We can do it, or we can do it for all the wells together. So we can go to wells, right click, import, and go to folder well deviation. I'm sure that all of you has a copy of the data. I need to define the file format, okay, which is the deviation data and well tops. Now we upload the fault data. Okay, the fault data in this project was picked by geophysicists in time domain. Okay, and you know that we need this faults method to build and characterize the structure in the structure model. Usually, geophysicists, they work on the fault, when they work on the fault data, they export the fault in different format that can be uploaded to the model to build a fault model and characterize structure model. So I will show you some forms or some shapes that faults can be input into Petrel. Faults can be input as sticks, okay, in this way. So each fault will be as a group of sticks, or it can be input into the model as polygons. So you have some polygons here, okay? So you have a point here, point here, point here, and you have a line connect between them. You have another one here, point here, point here. This is another polygon, okay? Another polygon here. Okay, so this is a fault, okay, as polygon. Okay, this is as fault stick, a polygon. And sometimes faults is exported to the geology modeler to input it into the model as boundary. So what does the geophysicist do is to provide a boundary of the fault that goes something like this. So this represent the age of the foot wall, and this A represent the age of the hanging wall. So when it comes to cross section, you this one represent this one, and this one represent this one. So these are the three different forms of faults that use in the model. So you have the fault stick, you have the fault polygon, and you have the fault boundary. Fault boundary is not recommended because you will do the model, you will do the fault model with uncertainty in the angle and the and the displacement magnitude of the fault. So it's always preferred to work as fault sticks or fault polygon, which is usually exported or which is the result of conversion fault sticks into fault polygon. So now I want to upload the fault sticks of my reservoir. I come first to folder and choose, oh, not here, no, okay, I choose a new folder. Okay, I call it, I double click on it, I open the setting window, I go to the name and call it fault, fault sticks. I can call it in time. So that I refer so that I defined my fault sticks as in time. So when anyone work on the model, okay, with me or after me, okay, know that these fault sticks are in time. So naming the folders is very it's very important, as it saves a lot of time uh, when someone is working on the project with you. All right, now we go to upload our faults. So we go to faults folder, fault sticks in time. I click on it. Okay, I choose the Z map lines because the format of the faults is several. Okay, in Petrel, so you have all these formats you can deal with. You have the Z map, you have the Eclipse, you have the CBS tree. Okay, you have also the Charisma. Okay, when you work on seismic perspective, you will have also the Charisma fault format. you know there are different softwares dealing with all these different formats like Sysmage, Petrel, Charisma, and more others. So in this case, our faults are in ZMap lines, which is this one. I choose it. Okay, I highlight all my faults and go to open. I get this window. We need to pay attention in this window. Okay, so it defines the names of the faults. Okay, and here the template was assigned, okay, by Petrel as the elevation and depth, which is not right, because all the faults were picked in time domain, not in depth domain. So what I need to do in this step is change the template from elevation time to elevation depth. This is a very, very important step you need to pay attention to. If you have a data in time, you need to upload it in time domain as a time data, not it's not proper to import data in time into a depth domain, which is not proper. But so once you do that, the X, Y, and Z range will change to the Z will change to millisecond. Do not do any conversion to Z, and you click OK for all. This is a confirmation for the CRS. You just click OK, and here when you click on the small arrow, you get all your faults and time domain. To display, click on the folders, and these are all the fault sticks in your field. So this is all your fault sticks that you will be using to do the fault or to do the uh, structure model. You can see that they are uploaded, as we said earlier, as a form of sticks or the fall or fault sticks. Okay. uh, to characterize these faults, if it's to confirm, okay, to confirm that these faults are in time domain, you can come to the status bar here and click on the small arrow, okay, and choose TWT. What's TWT? It's two-way time. Okay, two-way time. You click on it. This is confirmation. You see how the well data disappeared. Why the will that disappeared? Because we are showing the project or the reservoir or the fault sticks in time, or the objects in time. So only the time related data will show, not the depth. So that's why the will logs and the will heads and the kilibashing, everything disappeared because this is a time domain, not depth domain. Now if I go and click on TVD, you see, the faults in time disappeared while the depth data or depth related data showed again. If I want to show all of them, the time and depth together, I go to any and they will show together. So we have depth related data and time related data. Now I come to the next important data, which is the seismic horizons. I need to upload the seismic horizons to finish